All right, last part of this section is dividing, and let's go ahead and divide. And ask us for 2 on this. We want f over g first. So f is root x. G is the square root of 4 minus x squared. And so that would be our answer for f over g of x. Conversely, if we tried g over f of x, we end up with the root 4 minus x squared on top and the root x in the denominator. So the important thing here is we need to figure out the domains of both of these solutions. So on this one, if we're looking at this problem, we know a couple things. X has got to be greater than or equal to 0 because we cannot have 0 under square root. And that's going to be true in both cases, both f over g and g over f. We know that 4 minus x squared has got to be greater than or equal to 0. And then just for f over g, we know that the square root of 4 minus x squared cannot equal 0. These two are common to both f over g and g over f. The unique situation for g over f is going to say square root of x cannot equal, what can you not have in the denominator? 0. So let's simplify all of these things and see what we get. We could square both sides, still have 0. 4 minus x squared cannot equal 0. So 4 cannot equal x squared. So plus or minus 2 cannot equal x. We also know that x has to be greater than or equal to 0 from right here. So negative 2 would be no good. And so we would just say we know we can't be 2. And let's go ahead and solve for this one here. 4 is greater than or equal to x squared. And if we go ahead and square root, we're going to say x has got to be greater, got to flip it around. X is less than or equal to 2, or x is greater than or equal to negative 2. If you dig back in your brain into algebra, when you do inequalities, if you ever have to flip the sign from a positive to a negative, we have to flip the inequalities from less than to greater than. So let's go ahead and put all three of these things together. We know that we have to be greater than 0. Let's look at a number line here. 0. We know that we have to be greater than 0. We have over here, we have to be less than 2. We know we have to be greater than or equal to negative 2. But we also know we have to be bigger than 0. So this is kind of a duplicate here. We know that we cannot equal 2 from right here. So we're going to have a closed circle on 0 because we could equal the 0. But then we cannot equal 2, so we'll have an open circle here. Everything in between it. And so what we're looking at here, if we write it in function notation, would be from 0, touching it, to 2, not touching it. Let's go ahead and look at g over f as well. So x has got to be greater than or equal to 0. X has got to be less than or equal to 2. It has to be greater than or equal to negative 2. These three things I knew from what we had already figured out. We also need to solve the one specific situation just for square root of x being in the denominator. So if we square both sides, we're going to say x cannot equal 0. So if we look in this situation, we're going to have to get rid of the equals part and just say x is greater than 0. So we need to be bigger than 0, less than or equal to 2, and then this is a duplicate here again because we already know we have to be bigger than 0. And so on a number line, it would be the number 0 and the number 2 with open and closed circles. Function notation would look like parentheses on the 0 because we can't touch it, bracket on the 2. Whew, that's a big one. Go ahead and see if you can pull that off for yourself on 9D. All right, here we go. 9D, f over g of x equals x plus 2 over x minus 2. And in this situation, there is no problem with the original f for the domain. X could be any number. There is no problem with the original g. There's no square roots, there's no denominators, so we're fine. The only problem we come to is that when we put them together for our answer, we see that x minus 2 cannot equal 0. So for our domain here, we're going to say all real numbers, x cannot equal 2.